All right, wanted to welcome everybody today to our FAA System Safety Workshop. We appreciate you joining. We've got a great session for you this morning, or this afternoon, or this evening, whatever time zone you happen to be in, but we appreciate you joining us. Today, for our presenters, we will have two of our experts in the area of system safety. We've got Christopher Vance and Joe Leal, and I'm not sure which one of you gentlemen is going to be starting speaking, but I'll go ahead and hand the session over to you with a couple notes for everyone on the workshop. We are recording these for use for future viewing by other folks. And if you have a question during the session, please use the chat function that you can see at the bottom of your screen. And just enter your questions into the chat. We'll take them as we have time. But let me go ahead and hand it over to our speakers, and we'll get started with the presentation.
All right, good morning, good afternoon, good evening. Christopher Vance, the manager of the System Safety Branch and the Safety Analysis Division in the Office of Commercial Space Transportation. And let's go ahead and get started. So over the next few sessions, we have a session today and 3 more sessions after this. We're going to be discussing an overview of Part 450 System Safety. We're going to be touching on 450-103 System Safety Program, 450-107 Hazard Control Strategies, 450-109 Flight Hazard Analysis, 450-143 Safety Critical Systems Design, Test, and Documentation. Talking about some of the other additional safety critical requirements within the regulation, and ending with 450-141 computing system safety and 450-139 toxic hazards for flight. For 143 and 139, the ACs have not yet been published, so the information is currently in draft form, and information may change upon publication of the AC. Next slide. So system safety at the FAA has experienced an evolution over the last 20 years. We started a lot of our regulations were part 415, 417, and those were system safety via prescriptive regulations. Moved into part 431, 435, specifically for reusable launch vehicles and reentry vehicles, and part 437 for experimental permits, which was system safety via process-based regulations. We had a Tiger team in 2019 to assess our current practices for system safety related evaluations. And really just trying to ensure that we were completing system safety for public safety. And we rolled that into 450. 450 is system safety centric with performance-based regulations and prescribed hazard controls. And a lot of the lessons that are the things that came out of our Tiger team, we rolled into revisions to the 450 as it was being published where we could, or and into the guidance that was developed. In all, though, public safety is a central focus of AST system safety, and that includes waterborne vessels and air traffic. Next slide. All the primary advisory circulars and workshop material is going to be found, if it's published, is going to be found on our website at the following location. A little background on ACs. ACs provide guidance on AST's streamlined commercial space regulations. The goals of the ACs are to further explain the meaning of the regulatory text and its intent and provide a means of compliance. As such, the ACs are guidance. They are not a regulation, and so compliance is voluntary. However, to demonstrate compliance using a means of compliance found in an AC, the entire AC must be implemented, and this means that the FAA must approve any variance from a should statement in the AC. Next slide. As far as all other ACs, they are found at the website and in the following locations. Comments and questions in this workshop and in all of our workshops are considered in future revisions. Next slide. Any questions, initial questions before we get started into 45103?
And I'd like to remind everybody that if you do have questions, to use the chat function at the bottom. We will be taking questions and then we'll read them and have our subject matter experts answer as we go along. And I don't see any questions so far, Christopher, so why don't we go ahead and keep going?
All right, toss it over to Joe Leal.
Thank you, Christopher. So next slide. Let's see. So we're going to start off by looking at 45103, which is our system safety program. Next slide, please. So all of this guidance is taken directly out of the advisory circular. So we'll talk about that on the next slide. The figure that you see here is figure 1 out of the advisory circular. This is meant to convey just a generic life cycle of a launch and re-entry vehicle. So you can see in this figure, we've got 6 phases for our life cycle. So phase 1 being design, develop, and manufacture. Phase 2 being pre-launch, ground safety, and so forth. So you can see that along the life cycle, we encounter different hazards that require management. And, of course, 6 is post-mission. But this is an iterative process. And as we, launch more vehicles and look at our post-flight data, we not only refine our hazard management approach, but we learn whether our assumptions in our analysis were correct, and we iteratively update those. So with that said, an operator must implement and document a system safety program throughout the life cycle of a launch or reentry system that includes the following. A is a safety organization, B, hazard management, C, configuration management and control, and D, post-flight data review. An effective system safety process should be incorporated throughout the life cycle of the program, as public safety hazards associated with systems and operations of a launch or reentry vehicle are generally reliant on sound design, manufacturing, and operational processes and procedures that span the life cycle. Next slide, please. So what you'll find is that all of these lessons that we're going to go through will reference a section of the advisory circular. So if you're following along, you'll find that this slide, for example, is referencing section 6.2 that's called Context for System Safety Program. And this summarizes the items covered there. So section 6.2 is called Context for a System Safety Program. And the scope of the system safety incorporates all elements of the program that contribute to achieving compliant operations. Section 45103 specifically deals with organizational structures and management process and principles relied upon for ensuring that hazard controls and analysis correspond to actual operations. So just a disclaimer, what you're going to find is, this AC deals with not only the organizational structure, but all of the processes that have to be in place to achieve hazard management. The SSP documents the core processes that ensure that the fundamental risk requirements of 45101 and the system safety risk criteria of 45109B3 and 45185C are met over the life cycle of the system. So as far as 45101, this covers public risk criteria, and this states public and property safety criteria that must be met before an operator initiates the flight of a launch or reentry vehicle. 109B3 deals with the flight hazard analysis risk criteria, and this says that each flight hazard analysis, if it's required, must ensure that the likelihood of any hazardous condition that may cause death or serious injury to the public is extremely remote. And we'll talk about our flight hazard analysis in a different lesson, and we will talk about risk in the next few slides. As far as 185C, that deals with ground hazard analysis risk criteria, and there are a couple of likelihoods that must be met for not only public property, but also the public itself. Next slide, please. So this is figure 2 of the advisory circular in section 6.2, and it's called the context of 450-103 in part 450 safety requirements. So this is a really nice slide to begin with, because it shows how hazard management is tied into the life cycle of a system. And what you'll find is on the left-hand side, we have the hazard management process. And just to point out, you can see that configuration control is the foundation. So we'll talk more about that in a minute, but in the middle, you can see how this process provides data for parts of 450. And then what comes out of that are items that, feed into the safety organization, as well as inputs to post-flight data. And as you can see, there's a couple of other outputs, which we'll talk about in a minute, but you can see that it is an iterative process. So it feeds back into the hazard management system after each mission. So to begin with, on the left-hand side, hazard management is the assessment of the system and communication of this assessment to personnel implementing the remainder of the safety requirements. So when we talk about assessing the system, what we're doing is we're looking at our hazard control strategy and all of our analysis, and we're making sure that it actually relates to actual operations. So hazard management, you can see that assessment and communication are key. And what this does is it provides data, and it drives updates to parts of 450, which are captured in the middle. So just to kind of go through some of these sections, we have other prescribed hazard controls, which are 450, 147 through 177. Some of the items you'll find there are safety critical personnel qualifications, 161, control of hazard areas, and 173, mishap plan reporting, responses, and investigation requirements. And as you can see, configuration control is key there also. In the middle, we have our hazard analysis and control strategies. So these are captured 450-107 through 450-111. So these control strategies, which we'll talk about later, are captured here. 107 deals with hazard control strategies, and those are a 108 flight abort, a 109 flight hazard analysis, a 110 physical containment, and 111 wind weighting. And of course, we have our flight safety analysis, which is covered in 450-115 through, 450-113 through 139. So some of the items found there, for example, are 115 deals with the flight safety analysis methods or the methodology. The debris analysis is founded in 121, and 123 deals with population exposure analysis. And then ground safety covered in 450-179 through 189. So some things covered there, for example, 181, coordination with a site operator, 183, our explosive site plan, and 185, the ground hazard analysis. So these are all inputs that are driving, compliance to 450. So as you can see, there's a box that it drives inputs to decisions that the safety organization must, implement in operation. So the outcomes of, for example, the functional hazard analysis, the hazard control strategy determination, the flight hazard analysis, and the flight safety analysis, the FSA, should be implemented in the actual operation under the authority and responsibility of this safety organization. And as you can see, we have a block for post-flight data review. So post-flight data review, 450-103D, after each operation, it allows for determining and implementing necessary updates to the hazard management approach and processes before future operations. So you can see this will drive changes if required, or it'll give us the opportunity to see that you're addressing anomaly impacts. And this is iterative. So as we feed back into the hazard management box, you can see that this is continuous. It's an iterative process throughout the entire life cycle, and it should be founded on configuration management, which we'll cover in the next few slides.
So Joe, let me
Yep.
interrupt you here for a minute. We got a question that came in, so I'll go ahead and read it to you.
Sure.
How the guidelines from the AC are considered or implemented in the FAA licensing process to which operators need to comply with to be granted for a launch license. So the question is just, how are the guidelines implemented in the licensing process?
So as far as how they're implemented, we have typically a document that covers your system safety program plan, and you describe and give enough detail for not only how the organization is set up, but also all of the processes. How do you perform configuration management and control? And if there are any questions or parts of the advisory circular do not make sense, we do have frequent exchanges of information that we call TIMs. And these are just meetings that you can schedule at any time if you have questions, and we can review your documentation and provide either comments or updates that you can make. So as far as how it's implemented, it's implemented by providing documentation to us that we review in the license application, and we just will provide feedback and help you achieve compliant operations. Christopher, did you have anything else to add?
Yeah, I think you really hit it at the end. Guidelines and means of compliance of our ACs as they're utilized are documented in application materials, and the application materials then are submitted and provide the compliance evidence of meeting the regulation. I will also say that for the system safety program, some operators or applicants have utilized one document, but generally to demonstrate compliance to all of 45103, it requires multiple documents to be submitted, which is fine as well.
Okay. Next slide, please. Okay, so paragraph A deals with the safety organization. So an operator must maintain a safety organization that has clearly defined lines of communication and approval authority for all public safety decisions. And at a minimum, the safety organization must have the following positions: the mission director and the safety official. And the requirements for the mission director is that for each launch or re-entry, an operator must designate a position responsible for the safe conduct of all licensed activities and authorized to provide final approval to proceed with licensed activities. This position is referred to as the mission director in this part. Now, the safety official, for each launch or reentry, an operator must designate a position with direct access to the mission director, who is responsible for communicating potential safety and non-compliance issues to the mission director, and is authorized to examine all aspects of the operator's ground and flight safety operations, and to independently monitor compliance with the operator's safety policies, safety procedures, and licensing activities. And all of the safety officials' concerns must be addressed by the mission director. So there's a key item there is that the mission director must ensure that all of the safety officials' concerns are addressed. Next slide, please. So this is figure 3 in the advisory circular. And it's just an example of the safety organization. So we encourage you to use a figure like this that will show you how the safety official and mission director interface with the safety organization. So Section 7 of the AC is called Safety Organization. The establishment of a system or a safety organization is critical. It's a critical component of a launch and mission operation and public safety, whose primary responsibility is to carry out processes needed to protect the public safety, as well as identified in the system safety program. Now, 4017 deals with mishaps, and it has 9 definitions of what constitutes a mishap, and failure of a safety organization is one of those that are covered. The safety organization must have clearly defined lines of communication and an approval authority for all public safety decisions associated with a licensed operation or mission per 45103A. And again, we encourage the development of organizational charts like this that depict the safety organization and context of the larger organization. Next chart, please. So here we're going to discuss paragraph B, hazard management. For hazard management, an operator must implement methods to assess the system to ensure the validity of hazard control strategy, determination, and any flight hazard or flight safety analysis throughout the life cycle of the launch or reentry system. So we saw that figure earlier that was iterative, and that's really the key thing. We have a hazard control strategy, determination, and we have analysis that we need to look at to make sure that our assumptions were correct. And that tool is called our functional hazard analysis, which we'll cover in a lesson 450-107. So section 811 is called our functional hazard analysis. So this must be performed for all Part 450 license applications in accordance with 450-107B. And this is what provides for a methodical determination as well as continual validation of the hazard control strategy, the flight safety analysis, and the flight hazard analysis for each phase of flight during a launch or reentry operation. Now, we're going to cover this in detail later, so if you have questions, you can enter them in the chat. We'll discuss those after the lesson, but we're going to scratch the surface on a lot of things here. And the last bullet there, it should provide traceability for each functional source to the associated system and mission hazard during each phase of flight, to the respective hazard control strategy, to the verification evidence necessary for validation. So we'll cover all that in 107. Next slide, please. So here we have section 812 called reasonably foreseeable. So anytime you see that phrase, what this means is that it's readily discernible via analysis. So just keep, just interchange reasonably foreseeable with readily discerned via analysis. So reasonably foreseeable is not associated with a probability or likelihood, but it's inherent to the methodical assessment of the entire system. So as mentioned earlier, the functional hazard analysis is that tool that we see or that we use, and it's required for all 450 applications. It's expected that reasonably foreseeable hazardous events are those identifiable through the system safety process. It's beyond those that could be determined solely by brainstorming. And as mentioned, the functional hazard analysis is that system safety analysis tool primarily used to identify, classify, and analyze system functions and consequences of functional hazards associated with the conceptualized operation or mission. Now, the objective is to identify all pertinent potential system, subsystem, and component functional hazards that could impact public safety. And it's important to note that the identification of potential system hazards and respective functional sources should not consider any foreseeable mitigations, redundancy, or predetermined hazard control strategy. So what's that saying is that when you first look at these functions and the hazards that they may introduce, we want to make sure that when we start the process, we don't take credit for any mitigations. And when we get to 107, we'll talk about that in more detail. Next slide, please. So section 813, flight hazard analysis. The system safety approach of a flight hazard analysis may be determined as a hazard control strategy per 450-107A, or it could be required by 450-107 Charlie. So as mentioned, the flight hazard analysis is not only a, it's not only an accepted way to mitigate hazards. It's an accepted hazard control strategy, but it may also be required if none of the other hazard control strategies apply or mitigate public risk to the accepted level. So the documented SSP should define the methodology and the process for ensuring that continued validity in accordance with 450-103B1 and 450-109, and it should define a process for tracking hazards, risks, mitigation measures, and verification activities in accordance with 450-103B3. And we actually have an advisory circular for the flight hazard analysis, and that's AC 450-107-9, which we'll cover in the lesson for the flight hazard analysis. Now, in terms of the AC, section 814 is called flight safety analysis. So a flight safety analysis must be performed and documented in accordance with 450-113 through 450-139. And some of the items covered are things like the methodology, 450-115. There's also trajectory analysis there, 417 and 419, as well as debris analysis covered in 121. So there's several sections there that cover compliance for the flight safety analysis. And the documented SSP should ensure the validity of analysis and appropriate methodology in place to achieve these requirements. Next slide, please. So hazard management. For hazard management, an operator must implement methods for communicating and implementing any updates throughout the organization. Next slide. So section 8.2 in the AC is called managing updates. So in accordance with 450-103B2, the System Safety Organization ensures communication and implementation of any updates throughout the organization. The documented SSP should define tools and processes defined by the System Safety Organization to ensure that safety analysis data is effectively communicated, required actions and necessary updates are efficiently implemented, and the safety information is thoroughly organized and maintained. So we're going back to figure 1, which we looked at earlier. Also, the safety organization should be described in sufficient detail to clearly show how each of the divisions and roles within the larger organization will work to accomplish the goals of the system safety program. Now, for the system safety organization, the documented system safety program should at a minimum detail established lines of communication to management and engineering for informing of impacts to risk and to the public and necessary implementation actions to address impacts. So in essence, we want you to describe in enough detail all of the interfaces between the safety organization and external groups, which we'll talk about in the next few slides. Next slide, please. So section 821 is called organizational structure, and this is just an example system safety organization. So you can see that on the third tier, we have our system safety manager and different, groups that, are shown within this org chart. And these types of diagrams should be used to identify the system safety organization and also illustrate functional relationships as well as lines of communication within the program. So we encourage the use of these types of charts. Next slide. So as mentioned, we have 822, which is the integration chapter. The documented system safety program should provide clarity about how the different parts of the organization interface with the system safety organization and each other. And it should do the following. It should define the interfaces with functional organizations and other disciplines to include things like program management, systems engineering, design engineering, and so forth. It should also define interfaces with other applicable safety disciplines, such as software safety, range safety, nuclear safety, and so forth. And then the last bullet, it should define procedures for integrating and coordinating the system safety effort, including definition of system safety requirements within design specifications and operations documents, dissemination of system safety requirements to relevant organizations and contractors, support to program and design reviews, trade studies, and so forth. Next slide, please. So section 8.2, integration continued. It should also define expected criteria for interaction with configuration management processes, software development processes, data management processes, system and design engineering processes. And the interfaces and criteria should include requirements, data exchange, and communications. It should also describe tools used to convey safety information, such as a hazard tracking system or an internal workflow system. So we could have different databases as well as different workflows to accomplish the integration and exchange of information. Section 823 is called oversight in the AC, and an effective plan also includes oversight and tracking. So the documented SSP should define the management of contractors and subcontractors' safety, system safety efforts that have been procured to include integration of contractors' system safety analysis and data. Should also identify when formal approval action of safety documentation is required, by whom, and how that approval is documented. And it should also define processes by which management decisions are made, including timely notification of unacceptable risk, necessary actions, mishaps, anomalies, waivers to the system safety requirements, and program deviations. Next slide, please. So hazard management, the third item there. Additionally, an operator required to conduct a flight hazard analysis must implement a process for tracking risks, hazards, mitigation measures, and verification activities. So we talked about the criteria for when a flight hazard analysis is required, and tracking is critical. Section 8.3 of the AC is called tracking of flight hazard analysis data. Data tracking is essential for sound and continual valid flight hazard analysis. The documented SSP should define a process and a mechanism for identifying, detailing, tracking, collecting, and analyzing, as well as retaining flight hazard analysis data. And some examples of mechanisms are hazard reports, hazard database, systems engineering, management tools, etc. And as discussed in the advisory circular, AC 450-109-1, flight hazard analysis, traceability methods should be established for all relevant system safety requirements and analysis data. And when we get to our lesson on flight hazard analysis, we'll cover or discuss this more in detail. Next slide, please. So we talked about configuration management back in figure 1, and it was the foundation of hazard management. So paragraph Charlie states that for configuration management and control, an operator must employ a process that tracks configurations of all safety critical systems and documentation related to the operation. Must also ensure the use of correct and appropriate versions of systems and documentation are tracked in paragraph C1 of this section. And it should also document the configurations and versions identified in paragraph C2 of this section. So the next slide, please. So section 9, configuration management and control. The documented SSP should define the configuration management and control process specific for all safety critical systems and documentation. Standards for configuration management and control can be found in Military Handbook 61. The first version of this was released in September of 1997. And right now the current version is a version B, which came out in April of 2020. So you can reference this as one of the means for compliance for configuration management and control. Now, this configuration and management control process has to be defined in the SSP, and it should include lifecycle change modifications and redesign activity. Now, remember that as the functional hazard analysis evolves throughout the life cycle, this process should apply not just for known safety critical systems, but also track changes for potential implications in regard to public safety. Next slide, please. So post-flight data review, paragraph D, an operator must employ a process for evaluating post-flight data. And as mentioned, this is just to ensure consistency between the assumptions used for the hazard control strategy determination and any analysis that was conducted, the flight hazard analysis or the flight safety analysis and associated mitigations and hazard control measures. Also, to resolve any inconsistencies identified in paragraph D1 of this section prior to the next flight of the vehicle. Next slide. So section 10, post-flight data review. The review of post-flight data provides a valuable safety information on future operations. So the documented SSP should define the process for post-flight data review in sufficient detail that allows the FAA to evaluate and audit the process for compliance. As far as data collection, post-flight data should be formally collected, reviewed, and recorded, and the data should be used to identify trends in the context of previous flights and also gauge the effectiveness of corrective actions. As far as analysis consistency, if the flight data indicates incorrect assumptions or that the hazard management approach should be reassessed for any necessary modifications, and the inconsistencies must be resolved prior to the next flight of the vehicle in accordance with 450-103 D2. And this is also to ensure that there is no increased likelihood of system safety hazards to the public. Additional mitigation measures may be required, and the updated analysis should be used for future flights of the system. Next slide, please. So post-flight data review. So with that, we have to identify any anomalies that may impact any flight hazard analysis, flight safety analysis, or the safety critical system, or is otherwise material to public safety, and must address any anomaly identified in paragraph D3 of this section prior to the next flight as necessary to ensure public safety, including updates to the flight hazard analysis, flight safety analysis, or the safety critical system. And there's an asterisk there, but we won't talk too much about safety critical systems in this lesson, but those are identified through the functional hazard analysis, and we'll cover that more in 450-107. Next slide. Section 10.3 is titled Anomaly Reporting and Investigation. So anomaly reporting and investigation is essential for ensuring continually valid system assessment. And the documented SSP should define system safety involvement in the anomaly reporting, investigation, and resolution. The resolution process should be outlined for updating analysis and risks to address the anomaly, including any additional required mitigations, as well as for the periodic review of these analysis. The risk, and this can occur either before flight or after. And the FAA notes that if an anomaly constitutes a mishap, which is defined in 450.7, additional requirements apply. So 450.173 deals with mishap reporting, response and investigation, and there is an advisory circular for that. Next slide, please. So reporting to the FAA, in accordance with 450.215, a licensee must submit, among other things, information on any anomaly that occurred during the countdown of the flight that is material to public health and safety and safety of property, along with corrective action implemented or to be implemented after the flight due to the anomaly or mishap. And a summary of the flight anomaly, the closure strategy, and acceptance rationale should also be documented and provided to the FAA for review. Next slide. So application requirements. An applicant must submit the following in its application: description of the applicant's safety organization as required by paragraph A of this section, identifying the applicant's lines of communication and approval authority, both internally and externally, and for all public safety decisions and provision of public safety services, and a summary of the processes and products identified in the system safety program requirements per paragraph B, C, and D of this section. Note that submission could take form, as we mentioned earlier, it could be either one document or it could be a set of documents that span all of the requirements. Next slide. So now we're going to look at the appendix. So we have key aspects of a sound system safety plan. Appendix A1, system safety risk assessment. The risk assessment should be used for system safety for flight and ground safety, and it's generally qualitative, but there are instances when a quantitative demonstration may be possible or even necessary. So for system safety for flight, it is meant to augment or add the quantitative risk calculated by the flight safety analysis and inform the development and refinement of applicable mitigations. The operator must also assess each hazard's likelihood and severity per 450.109(b)(2) and 450.185(b). So we have likelihood requirements there. We're going to look at these in the next slide. We actually have a slide which we'll use to discuss these levels. Therefore, an operator should define severity categories and likelihood levels to ensure that the system safety requirements are met. And those criteria are found again in 450-109B3 and 450-185C. These severity categories and likelihood levels may be informed by industry practice or existing government standards. And utilizing a risk matrix allows for a more effective characterization of each system safety risk against unacceptable criteria. And you can use the MIL standard. MIL standard 882 ECHO is our DoD standard practice system safety guidance that is available. And right now, version ECHO, I believe, yes, it came out in May of 2012. Next slide. So this is table 3 of the AC. And what these are laying out are just 2 items, the severity categories on the left and the different likelihood levels that you could use on the right. So we encourage you to use something that is in the MIL standard or come up with your own severity categories that mirror what's in the advisory circular. So what you'll find is we have, different categories for the severity: catastrophic, critical, marginal, or negligible. And then for the likelihood levels during the mission, we can come up with different levels such as frequent, probable, occasional. Extremely remote, level E, is what we're interested in. So, when you categorize your risk, we want to show that the likelihood is extremely remote. And we'll cover this a little more when we talk about our functional hazard analysis. Next slide. So section 8.2, system safety requirements. So identification and implementation of system safety requirements within system engineering processes ensure the effectiveness and validity of system assessments. And the systems engineering process should be outlined for safety design requirements, for which objectives are to mitigate system hazards throughout a systematic application of design guidance from standards, applications, regulations, design handbooks, safety design checklists, and other sources. Safety design requirements should be included in the system specification and expanded for inclusion in the associated lower level specifications. Safety operational requirements should be included in procedures, tests, and inspection documentation, applicable rules or commit criteria, as well as items like operational clear areas. Next slide. Section 8.3 discusses the integrated schedule. So the system safety schedule ensures effectiveness of the system assessment throughout the life cycle of the program. So we want to not only track the schedule, but make sure that we line up certain criteria with the schedule. So the documented system safety program should detail the system safety activities and milestones within the overall program schedule, including product or task start and completion dates, reports, reviews, and safety milestones. Typically, the milestones of the system safety program coincide with license processes, program reviews, and other contract milestones. Thus, the schedule should detail the system engineering activities for which the system safety efforts are integrated, such as technical reviews, program reviews, design analysis, and test activities. Updates to the schedule and product deliveries in the plan should occur when license processing, contract, or design changes are implemented. And an operator should identify any interdependencies for safety task and artifacts. Next slide. So section A31 is integration with other program activities. And to be effective, the system safety activities for any program should be integrated to other program activities. And to be efficient, each system safety task should be carefully scheduled to have the most positive effect. A system safety analysis should be performed early in the design process, so it can lead to the inexpensive elimination of hazards through design changes. And what you'll find is that as hazards are identified later in the life cycle, it becomes more expensive and difficult, not only to change the design, but also almost impractical to design out of the system. And in such cases, what you'll find is that hazards are controlled through either operations or procedures, and also training. But having to do so is going to really force the operator to have long-term costs and risks associated due to identifying those hazards late in the design process. Next slide. So let's see. Yeah. Section A4, management of life cycle risk. Management of life cycle risk is essential for ensuring the continued validity of system safety analysis. Impacts to risk include design or operational changes. These are typically managed by change impact analysis. The impact should be determined for any changes to the design configuration or operation of the safety critical system. And again, there's an asterisk there. Safety critical systems are identified through the functional hazard analysis, and that'll be discussed, again, more 450-107 lesson. The current hazard management approach and hazard control strategy should be reassessed with respect to the change and update appropriately. Impacts to risk due to reuse of systems, subsystems, or components are typically managed by a reusability approach. Next slide. Section A5, system safety data handling. Data tracking is essential for a sound and continual valid system assessment. The documented SSP should define the process for identifying, detailing, tracking, collecting, organizing, and retaining system safety data. Examples of this data include test documentation and data, hazard reports, procedures, lesson learned, contractor deliverables, post-flight documentation, anomaly reports, and pertinent historical hazard or mishap data. Next slide. Section A6, consideration of additional system safety related tasks. A complete system safety effort should consider and integrate tasks and activities usually performed by other organizations or disciplines, including associate contractors, to ensure the sound, continual, valid safety analysis. So here we have different tasks located on the left-hand side. So different tasks are operations and maintenance, for example, training, reliability. And then the next slide, we have quality quality engineering and assurance. So you could see items there: software testing and acceptance, supplier selection, quality surveillance and audits, and so forth. So these are additional considerations of different safety related tasks that we should incorporate in the SSP. Next slide. So this is a summary of all of the key items that we covered. Figure 1 and figure 2 are paint a very good picture of hazard management. We talked about, how to implement and document a system safety program throughout the life cycle. 45103A talked about the safety organization with, at a minimum, having a mission director and a safety official. And paragraph A describes, what criteria must be met by the safety organization. 45103B, hazard management. We want to make sure that, you employ methods for assessment and validation of predetermined hazard control strategies, flight safety analysis, and so forth, as well as communicating and implementing these updates throughout the organization, and a process for tracking flight hazard analysis data. So figure 2, which we looked at. 45103C, configuration management. This is the foundation of hazard management. We have to employ a process for tracking, maintaining, and capturing configurations, versions of safety critical systems and documents. 45103D, post-flight data review. We looked at how to employ a process for evaluating post-flight data, and also aspects of a sound system safety program. So next slide. Yep. So as you can see, having a sound system safety program is key for hazard management. Any questions on the lesson? Christopher, do you have any more to add?
I do not. We
So did you see the question, Christopher?
did. So there was an incoming question about, are you able to provide examples of commercially available engineering tools to support the system safety program? As far as tools go, generally for data and task organizing and tracking tools, Doors, Jira, some of those industry type tools are utilized. For analyses, sometimes the fault tree analyses, which is a reliability tool that supports system safety analysis. Wind chill RELX tools exist. We don't mandate any particular tools, but we definitely encourage the use of available software to enhance the system safety program. Generally, a lot of the system safety is following sound system engineering processes. And a lot of that is documentation, data, Excel sheets or Word tables, and then utilizing, again, like those tools we discussed.
Thanks, Christopher and Joe. So we have time here in our presentation for any additional questions. If you guys have questions, then please use the chat function at the bottom of your screen to type those in, and we'll be glad for our subject matter experts to give you some answers. I'll pause here for a moment to see if there's any questions that might come in. While we wait for any questions that might come in, I'll remind everybody that this has been recorded. So if there's things that you would like to go back and reference, the FAA will let you know when those recordings are available. Or if you happen to have colleagues that were not able to join this webinar live, then we can make those video recordings available after the fact. We'll again let everyone know when they're available. Okay, I'll make one last call for any questions from the group.
remind them about the other workshop.
Okay, very good. Well, it looks like we've come to the conclusion of our session for today. Oh, looks like we do have one more question. Hold on just a moment. And Christopher or Joe, I don't know if you guys can see the question, but I can read it. Are you able to provide examples of, are you able to learn from errors in recent launches, even when companies may or may not be in business? Arguably, some very valuable lessons might come out of that.
We look at everything. So, I think as we talked about before, in 103, it's required to have a post-flight data review. So, at least now, we have the requirement that every operator documents and performs a post-flight data review, and that documentation is provided to the FAA. And then additional documentation as requested by the FAA is provided. We also have past data that comes from launches that have occurred in our office, where other analysis divisions have lessons learned and data that we gather internally and from external sources and from licensed operations. So yes, we do learn from all events, successes and errors.
Super. Thank you, Christopher. If there's no other questions from the group, then we will go ahead and close for today. Thank you so much for attending. I would like to remind everyone that there are 3 more sessions. The next one is going to be on Thursday of this week. It will be at 4 p.m. starting time, US Eastern. Please take a look at the meeting invites for, the WebEx dial-in information, or the Zoom dial-in information. And then we will have 2 sessions next week, also on Tuesday and Thursday. We look forward to everyone participating, and thanks so much for the speakers today. Hope everyone has a great rest of your day.